So we're going to finish off our discussion of recursion by looking at two other sorts that are order-wise more efficient than what we've done before. Our implementations aren't necessarily going to be more efficient. They're going to have a fairly high overhead to them, but they'll be reasonably simple. And both of these sorts use an approach that's referred to as divide and conquer. And this is a standard problem-solving technique in computer science, and in particular with recursive problems. The idea is that you take a large problem and you divide it into smaller problems, and then you take the solutions to the smaller problems and you put them together to build a solution to the whole problem. So this doesn't just work in warfare, it works for solving problems on computers as well. For our problems, the thing that we're dividing up is an array. And so we want to take an array and break it into pieces. And each of these different sorts is going to do the division and how they kind of conquer the problem in a different way. Now we're going to talk about the merge sort. Merge sort does a whole bunch of dividing and then builds back solutions from that. The quick sort moves things around as it divides and decides how to divide based upon something called a pivot, and then does all the work going down so it doesn't have to do anything to put the results back together as we come up. So we'll look at these individually in the next two videos. This divide and conquer approach can work for lots of other things as well. So when you are faced with a problem, one of the ways that you should try to think about it is, can I solve a small case, in a way that is very simple, so we have a base case, and can I take solutions to smaller problems and put them together efficiently in a way that makes a solution to a larger problem. If you can do both of those things, then you have something that is a good candidate for using divide and conquer.